So after solving for F12x and finding out it's negative 144 newtons, we're naturally going to want to look at the y force balance equation. But we very quickly realize that we have a value for M2Ag2x, but we have nothing for F32y and F12y. An equation with two unknowns means no solution. So, in order to find that solution, we need to look for additional information. We have done the force balance for the x and the y axes of the ConRod. Now what we need to do is the torque balance. Because if you recall, D'Alembert's principle says that the sum of the forces is equal to 0, and that the sum of the torques is equal to 0. So in order to sum the torques, what we're going to want to do is determine which point here we're going to take as fixed, and we will sum the torques about it. When we look at the setup of this type of problem, we are always taking the velocities and the accelerations of c with respect to b in order to generate numbers. So it makes sense for us to go ahead and call the b joint fixed for the purposes of summing the torques. That allows us then to ignore the forces that are acting on this joint because they have no moment arm under which to generate a torque about that fixed point. So let's start by writing down an equation that sums these torques. We have four total forces that are acting along some portion of this ConRod as a moment arm. And as you recall, when we're doing torques, we need to get the force that is perpendicular to the moment arm. So in the case of F32x, I'm looking for this force. F32y, in the same way, I draw a right triangle, I'm looking for this component. Same with all of these. So bear with me for a second, I'm going to write this down. Sum of the torques will be F32x. So this total force, I want to get this component. I know that this is 16.4 degrees, so just by geometry, I know that the opposite angle here is also 16.4 degrees. So I can say that this portion is going to be the sine of 16.4 times that force, sine of 16.4 degrees, and that force is acting at this point, so it's acting along the entire length of the ConRod. So I'll go ahead and plug that in. The ConRod length, you may recall from the initial setup, was 100 millimeters. So that's a torque component coming from F32x. We also have a torque component coming from F32y. And using the same reasoning, that's going to be cosine of 16.4 degrees times 100. So that's the torque components coming from both of these forces. We'll have torque components coming from two inertial forces. So I'll write those in the same fashion. M2 Ag2x times sine of 16.4 degrees times 50, because it's only working over half of this length. Sorry again for the phone. What happens when you've got lots of teenagers in the house? That is a negative, plus, again, negative M2 Ag2y cosine 16.4 degrees times 50. So again, the components that are perpendicular to the moment arm being half of the ConRod length, because that is the location of our center of gravity. We have one more thing to add in here, the inertial component of the resistant torque motion. So plus negative Ig2 alpha 2 equals 0. So this is the interpretation of D'Alembert's principle of summing torque for the ConRod. Now, we have a value already, as you recall, for F32x, and we have nothing for F32y. We have M2Ag2x, we have M2Ag2y, and because we were given a value for the polar moment of inertia of the ConRod, and we found its acceleration, we have a value for this. So let's see what we've got here. First we're going to have F32x times sine 16.4 times 100. F32x is the negative of F23x. So, let's see here. F32x is equal to 87. So that implies that the first component here is 87 newtons times, we'll go ahead and use meters, so 100 millimeters divided by 1,000, so 8.7 times the sine of 16.4. So that tells me that this first component, let's get rid of this, the first component is 2.5 newton meters. I don't know F32y, so I'm going to leave that for the moment. This next component, negative m2ag2x sine 16.450, that I can get a value for. So, let's see here. Plus m2ag2x. ag2x is right here. So it was 57, negative 57.4. I have a negative sign there, so it's 57.4. Let's see if I can get this up to where we can see it. 57.4 times the sine of 16.4 times 50 divided by 1,000, and I get a value. Seems a little low. What am I doing wrong here? I've got 282x 57.4, 2.87. There we go. So 0.81 newton meters for this component. For the next component here, I've got 28 newton meters times, again, 50 divided by 1,000 times the cosine of 16.4 plus 1.36 newton meters. I can get a value for the inertial portion. If you recall, our Ig2 is 300 kilogram millimeters squared. So, 300, I'll go ahead and convert that to meters, so divided by 1,000 twice. My angular acceleration was 2,692.2. So, my negative Ig2 alpha 2 is 0.81 newton meters. And then the last thing that I got is F32y times the cosine 16.4 degrees times 100, and I divide that by 1,000 for the conversion to meters. It's equal to 0. So now what I've done is figure out the torque component for F32x, that's 2.5, the torque component for the acceleration, or excuse me, the inertial force in the x-axis, 0.81, the inertial force in the y-axis, 1.36, and the inertial force based on the polar moment of inertia, negative 0.8. And I can solve for my single unknown of F32y. If I do that, what I find, let's go ahead and do that, 2.5, 0.81, 1.36, 0.8, and I multiply that by 1,000, divided by 100, divided by the cosine 16.4, I get that F32y is equal to negative 40.3 newtons. Now at that point, things start to cascade back out. So, if F32y is negative 40.3 newtons, I can substitute it in here and get a value for F12y. F12y then, and I won't go through the exact steps because that's pretty elementary, but I have a value for M2ag2y, F32y, and let's see here, negative 40.3, M2ag2y is 28, change sign. Let's make sure that makes sense. It looks like it does. So that says that F12y is equal to 12.3 newtons. So now I've solved this force balance. I can also take these numbers all the way back up to the piston. F32y is negative 40.3, so F23y is equal and opposite to it. That says that F23y is 40.3 newtons. So F03y is equal to negative 40.3 newtons. Alright, so that pretty much finishes up the ConRod. We'll move to another file in order to do the crank.